Hello everyone, I hope you all are doing great. My name is Anjali Shi and I'm an educator at Re-Level by Unacademy. I'm currently working with Microsoft as their senior software developer, and in this particular topic we are going to be discussing about application layer. Let me mirror my screen and let's get started. So our today's topic is application layer. So far you have learned about your OSI reference model. So in that particular one, we have here application layer as well. Today we are going to be speaking about it. So when we are going to be talking about your OSI layer, so in that one, your fifth layer is going to be your application layer. So we can say fifth layer in OSI reference model. All right. And when we are going to be talking about the application layer, so we have even discussed about the session layer. So the session layer was in the network dialog controller, and this layer is actually going to be allowing the users on the different machine to establish a active communication session between them. And the main aim of this layer is going to be establishing and maintaining and synchronizing the interactions between your communicating systems. So the session layer is actually going to be managing and synchronizing the conversation between any of the two applications, and in the session layer the stream of the data is going to be marked and we are going to be resynchronizing them properly so that the ends of the message are not going to be cut prematurely and your data loss can be avoided. So in this layer, one of the most important component of the OSI layer, we can say this layer is going to be the most important one in the OSI layer, and it is used by many computers and applications on the regular basis. When we are going to be talking about your application layer, so this one is mainly going to be defining about how to start, how to control, and how to end the conversation between your different applications. So this one is actually going to be your application to application. All right, so in this particular one, you are going to be having the session layer. So that session layer is going to be responding about the type of the service request which you have made from your presentation layer and whatever the issued service request you have received to your transport layer. So this layer is actually going to be responsible for synchronization and your dialog control and what and all services you are going to be having by your application layer. So whatever services we have, I'll just list it down here. So the first one is going to be your full duplex. The another one is going to be your half duplex. And then you are going to be having the simplex operations. So your simplex operations, and along with that you are also going to be having something like establishing checkpointing. Also you are going to be having like termination procedure and your restart procedure. So termination procedure, and restart procedure. All right. And when you are going to be implementing this layer at that particular time, you should be knowing that we are going to be performing all these services explicitly on the application environment, and how can we do with the help of your remote procedure calls. This layer is also responsible for finding and sending the data across your correct connection, and in order to set up and tear down the connection, your session layer is actually going to be performing all the communication. Now I will be just showing you how does this synchronization is actually going to be working. All right, so let me just show it to you. So we are going to be having your presentation layer. So let us say here you have your presentation layer, here you are having your session layer, and after that you are having your transport layer. So that is how it is going to be there. So what is actually going to happen? Firstly, your presentation layer is going to be sending the data from presentation layer to session layer. Then the session layer is going to be sending the data from session layer to transport layer. Now since we are going to be taking care of the synchronization. So you are actually going to be maintaining the same flow at the point of receiving as well. So how it is going to go? Firstly, it is going to be taking the data at the transport layer. Your transport layer is going to be sending it to your session layer, and session layer is going to be sending it to your presentation layer. So this is how it is going to be there, and you can see whatever data you have received, that is also synchronized. So that is how synchronization is actually enabled here. Now we are going to be discussing about the various protocols which we are going to be seeing in our session layer. All right. So we can say protocols in the session layer. All right. So what and all protocols we are going to be seeing here. So the first one which you have is your RPC protocol. So RPC protocol. So what is your RCP protocol? So this one is your remote procedure call protocol. So remote procedure call protocol. All right. What is the next one which we are having here? That is your SCP, that is your session control protocol. So the second one is SCP, that is session control protocol. After this, we are going to be having PPTP. So what is the PPTP? That is going to be your point-to-point tunneling protocol. So PPTP, point-to-point tunneling protocol. After that, the next one which we have is your PAP. So what is your PAP? That is your password authentication protocol. So your PAP is password authentication protocol. The last one which we have is your RTCP. But your RTCP is real-time transport control protocol. So RTCP, real-time transport control protocol. All right. So these are going to be the various protocols which we are going to be using in your session layer. Now we are going to be discussing about the various responsibilities of your session layer. So responsibilities of session layer. So in this particular one, what and all responsibilities we are going to be taking care. So the first one is going to be your dialog control. So what actually we do in your dialog control, So what we do in your dialog control, so in this one, your layer is going to be allowing two systems that will actually start communicating with each other, either in your full duplex or half duplex mode. All right. The second one is going to be your token management. So what is a token management? So this layer is going to be providing the two parties from attempting the same critical operations at the same time. And the last one which we have is your synchronization. So what synchronization is? So this layer is going to be allowing the process of adding the checkpoints, which are going to be considered as the synchronization points into the stream of your data. So let us say your system is actually sending a file which is having, let us say 800 pages. So after adding the checkpoint after every 50 points is actually recommended. So what is going to happen after every 50 points, you can actually see how your data is actually going to be delivered. So this is also going to be ensured that your 50-page unit is successfully received and acknowledged. This is also beneficial at the time of the crash, as if your data happens at the page number 1110. So there is no need to retransmit 1 to 100 pages, you know where it has actually crashed, and from there only you are going to be going ahead and addressing it. Now let us look into what and all functions do we have for our session layer. So session layer is actually going to be establishing the session between the session entities. This layer is also going to be responsible for your data transfer phase. This layer is going to be used to select the required transport quality service parameters. This layer is also going to be used to identify each session, and this layer is going to be used to transmit a limited amount of transparent user data. Now we are going to be talking about the presentation layer. All right, so what do we have in our presentation layer? So this layer is actually going to be the layer 6 of your OSI reference model. So sixth layer of OSI reference model. All right, also when we're going to be talking about your presentation layer, so this layer is going to be responsible for sending the service request from your application layer, and whatever the issues you're going to be getting at your service request to your layer 6, that is going to be your session layer. In this layer you are going to be having, like, this layer actually going to be acting as a translator of the network. And what is the another name of the presentation layer? That is the syntax layer. So what is the primary goal of this layer? Is to take care of the syntax and semantics of whatever information we are exchanging between two communicating systems. And this presentation layer is also going to be taking care of the data which you are sending, that the receiver is going to be understanding the information and it will be able to use the data. So whatever the languages which we are going to be using, they can be different between the two communicating systems, and under this control your presentation layer is going to be playing the role of a translator as well. Now in order to make it possible for the computers with the different data representations to communicate, your data structures to be exchanged can be defined in an abstract way. So your presentation layer is going to be managing these abstract data structures, and it is also going to be allowing the high level data structures. Now I will be quickly showing you how it is actually going to be there. So this one is going to be your, this particular one is going to be your presentation layer. Now here we are having some of your session layer, and here we have your application layer. Here we will have our header and your send data. So what will happen? Your session layer is going to be sending both of the things, but from your application layer you are only be getting the data part. Similarly, when your session layer has to send something, so what it will do, this is how you are actually receiving it, but if you will have to send, so at that particular time it is not going to be taking the header, it is only going to be taking the data part. So that is how it is going to be there. So if we have to talk about the presentation layer, we can say that presentation layer may represent or encode the data in various ways, like your data compression, data encryption, but the receiving device mainly decodes or converts the encoded messages into the original form. So for the same data, the sender and receiver may need to agree upon a messaging format, which is also known as a presentation format. And this presentation layer is going to be a part of your operating system, which is going to be converting the data from one presentation framework to the another one. Now we are going to be discussing about the various protocols which we use at the presentation layer. So protocols used at presentation layer. So what and all protocols we are going to be having here? So the first one is going to be your AFP. So what your AFP is? AFP. So your AFP is actually Apple Filling Protocol. The next one which you will be having is going to be your SSL. What the SSL is going to be there? That is your Secure Socket Layer. And this is most commonly used. Secure Socket Layer. The next one which we will have is your FTP, and that is again widely used. That is your File Transfer Protocol. FTP. File Transfer Protocol. Then we are going to be having Telnet. We are also going to be having the LLP. LLP is also called as Lightweight Presentation Protocol. lightweight presentation protocol. And the last one which we will be having is going to be your SSH. So your SSH is nothing but your secure, and the last SH is for shell. So this one is going to be providing the secure shell. So these are going to be the various protocols which we have it as presentation layer. Now we are going to be discussing about the various functions of your presentation layer. Functions of presentation layer. So what and all functions it is going to be having. So the first one which we will have is going to be your translation. So what we do in the translation, so whenever you will have to send a data, so before transmitting it, so whatever the information you have in the form of characters and numbers, that should be changed to your bit streams, and your presentation layer is going to be responsible for the interoperability between your encoding methods, as the different computers are going to be using different encoding methods. It also translates the data between the formats the network is going to be requiring and the format of the computer. The second one which this presentation layer does is going to be the encryption. So what do we mean by encryption? It is going to be carrying out the encryption at the transmitter, and it is also like at transmitter it is going to be like you're going to be having a transmitter and you're going to be having a receiver. So what it will be doing at the transmitter, it is going to be encrypting it, and at the receiver it is going to be decrypting it. And why it is actually beneficial? So that nobody can actually, like, even if somebody is taking out the data, it is not going to be reading it out in the normal way. So it's always a safer option to encrypt the data when you will have to send it across the network. The next one which we have is your compression. So what we do in the compression, it is going to be carrying out the data compression so as to reduce the bandwidth of the data to be transmitted. And the primary role of your data compression is to reduce the number of the bits to be transmitted. And it is also important that when you are going to be transmitting your multimedia, let us say your audio, video, or your text, in such a case you are actually compressing it, otherwise it will end up taking a lot of your storage. Now, what and all are your design issues with your presentation layer? So, when you have to talk about the presentation layer, it is actually difficult to manage and maintain the syntax and semantics of the information transmitted. In this particular way, in this particular case, also, whenever you are going to be performing the encoding on your standard data, that is also going to be one of your issue. And whenever you're going to be performing the encoding on the wire, so that is also going to be one of your issue. Now the next one which we have here is application layer. So when we talk about the application layer, in this particular one we are going to be talking about the various protocols. So the first one which we have is your HTTP protocol. So what is your HTTP? That is your hypertext transfer protocol. Hypertext transfer protocol. So when we are going to be talking about your HTTP, so in this particular one, we are mainly be using it in order to access the data from your World Wide Web, and the HTTP is mainly going to be functioning as the combination of your file transfer protocol and your simple mail transfer protocol. Now your HTTP is one of the protocol which is used at the application layer. The HTTP is quite similar to your FTP because HTTP is also used to transfer the files, and it is mainly going to be using the services of your TCP. The HTTP is quite simpler as compared to your FTP because there is going to be only one TCP connection. In your HTTP, there is going to be no separate control connection, as only data is transferred between the client and the server. The HTTP is actually like your SMTP because the transfer of the data between the client and the server is going to be simply looking like your SMTP message, but there is going to be a difference unlike SMTP. The HTTP messages are not destined to be read by the humans, as they are read and interpreted by the HTTP client, and your HTTP server. Also, when we are going to be talking about the SMTP, so the SMTP messages are going to be stored and then forwarded while your HTTP messages are delivered immediately. Your HTTP is mainly going to be using the services of the TCP on the well-known ports, that is your port number 80, and your HTTP is actually a stateless protocol. So in the HTTP, the client initializes the transaction by sending a request message and the server replies by sending a response for the same. Now I will be showing you how does your HTTP actually works. So here you are going to be having a client, and here you are going to be having a server. So what is actually going to be happening? So this client is going to be making a request. So this server is going to be seeing that okay, it has received a request. So for that particular one, it is going to be performing a response back to the client. So this particular one is actually going to be using a client server architecture, and in this particular one, your browser is actually going to be acting as the HTTP client, and that client is going to be communicating with the web server, which is going to be hosting the website. And the format of the request and the response message is actually going to be quite similar to each other. The request message is mainly going to be consisting of the request line. It is also going to be having a header, and sometimes even it is going to be having a body. And the response message, like actually I'll write it down. So for your request message, so what and all it is actually going to be having, so it is going to be having a request line, it is going to be having a header, and it is going to be having a body. All right, now if we will be looking at the response message, so response message is going to be having a status line, response message. So that will have a status line. It is also going to be having a header and sometimes a body. So you can see they both are quite similar to each other. Only difference is in this one you have a request line, in the response one you are having a status line. And at the time when the client is going to be making a request for some information to the web server, so that the web server is going to be sending a request message to the HTTP client for the requested object. And after that, what is going to happen? There is going to be a connection that is going to become open between the client and the web server through the TCP. And after that, your HTTP is going to be sending a message to the server that is going to be collecting the requested data, and the response which we are going to be sending with the objects is going to be sending back to the client by your HTTP, and at the end HTTP is going to be closing the connection. That closing of the connection and opening the connection is actually very important here. All right, now if I have to actually draw it down, how does this one, the format for this one is going to be looking? So it is going to be like this. On the top we will be having your request line. Here I'm actually trying out the format for the same. After that we are going to be having a header. Then you will be having a blank line. And after that we are going to be having a body. So when we are going to be talking about the body, so it is present in some messages. It is not going to be there in all of the messages. Now if I have to draw the format for your response one, so it is going to be the same. On the top you will have a status line. After the status line you are going to be having a header. After a header you will be having a blank line, and after a blank line you have a body which is not going to be available in all of the messages. Very few will actually have your response messages. So that is how it is going to be there. Now let us discuss about the features of your HTTP. So your HTTP is having lots of features. One among them is it is quite simple. Your HTTP protocol is designed to be plain and it is human readable. When we talk about the HTTP, so it is a stateless hypertext transfer protocol, and it is a stateless protocol, which simply means that there is going to be no connection among two requests that are being consecutively carried out on the same connection. Also, both your client and server is going to be knowing each other only during the current request, and thus the core of the HTTP itself is a stateless one. On the other hand, HTTP cookies provides in making use of the stateful session. HTTP is actually extensible, so the HTTP can be integrated easily with the new functionality by providing a simple agreement between the client and the server. And your HTTP is connectionless, so as the HTTP request is going to be initiated by the browser and as per the request information by the user, and after that the server processes the request of the client and then it is going to be responding back to the client. Now we are going to be discussing about what and all advantages do we have of HTTP. So the first one is there is no runtime support which is required to run properly. Also, when we talk about HTTP, it is a platform independent. It is also going to be offering reduced network congestion, and this one is going to be reporting the error without closing the TCP connection. Your HTTP is actually going to be usable over the firewalls and your global applications if that is possible. And since it is connectionless, so there is going to be no overhead in order to create and maintain the state and information of the system. Now let's look into what and all are going to be the disadvantages of HTTP. So your HTTP is not optimized for your mobile. Your HTTP is actually verbose, and it can also it can only be used for point-to-point connections. And when we are going to be talking about HTTP, so this protocol is not going to be having any of your push capabilities. This protocol does not even offer the reliable exchange without the retry logic. Now, what and all connections are going to be there for your HTTP? Let's just write about it. So your HTTP connection. So we are actually having two types of HTTP connection. So the first one is going to be persistent connection, and the second one is going to be your non-persistent connection. Alright, so when we are having these types of connections, you will be knowing the persistent is the one which is going to retain, non-persistent is the one which is not going to be retaining. Now let's discuss about electronic mail. Alright, so this electronic mail is also known as your email, which is very widely used. So in this particular one, what we do, why do we actually use it? So this one is actually going to be useful or exchanging your digital messages. Your electronic mail is designed mainly for your human usage, and it is also going to be allowing to send a message which is going to be including your text, images, audio, as well as the video. This service allows one message to be sent to one or more another, like we can have one or more than one recipients for the same. Your email system are actually based upon your store and forward model, where the email service system accepts and forward and deliver the and store the messages on the behalf of the user, who only need to connect the infrastructure of the email. The person who is going to be sending the email is actually known as sender, whereas the person who is going to be receiving is known as recipients. Now I will be just showing you how does it actually work. So I am going to be showing you the components for the same. So the components of an email system. So we are basically going to be having three components for the same. So the first one which we will be having is going to be your user agent, which is also called as UA. The second one which we will be having is going to be your message transfer agent, which is going to be your MTA. And the last one which we will be having is going to be your message access agent. So these are going to be the three components which you are going to be using in the form of your email. Now let's talk about your DNS protocol. So what is your DNS? DNS is called as your domain name system. Alright, so when we are going to be talking about it, so in such a case, we are going to be having Like in this particular one, you are going to be having it on your application layer protocol, and what is the usage of your DNS protocol. So your domain name system is actually supporting the programs which are actually used by your other programs, such as your email. The user of your email actually knows the email address of the recipient, and your internet protocol is going to be needing your IP address. Mainly your DNS client programs are going to be sending a request to your DNS server in order to map the email address to your corresponding IP address. In order to identify an entity, the TCP IP protocol is also going to be making the use of your IP address, which is going to be uniquely identifying the connection of host to the internet. But people usually prefer to use names instead of numeric addresses. Like if you will be actually looking into, yeah, like google.com, so you're not going to be preferring if it is going to be available like something like 192 or 168, something like. You are going to be preferring if it is going to be in that form. How it is actually going to be helpful, because it is going to be readable, right? So now how does it actually work? I'll show you how does your DNS actually works. So you are going to be having your SMTP client. So to your SMTP client, you are actually be sending some of your, like some of the user is actually going to be using it, and let us say it is like abc@gmail.com. I'm just taking some example, and this one is happening at the application layer. What is going to happen? This one is going to get converted to some IP address. All right, and here you will be having your DNS. So what will happen? This SMTP is going to be communicating with your DNS. So how it is going to happen? It is going to be using your gmail.com, and this DNS is going to be returning you the IP address. So let us say 198.162.1, and then here you are going to be having another of your DNS client, and this DNS client is again going to be using this same gmail.com and returning the address. And all of these things we are actually going to be performing at your application layer. So this is what your DNS is actually going to be doing here. So in this particular one, what do we actually use? We use the namespaces. How those namespaces are going to be helpful? So those namespaces are going to be mapping with each address to a unique name, and these names are going to be assigned to the machines that is also going to be unique because their addresses are unique. Now this particular one is divided into two parts. First one is a flat namespace, and another one is going to be a hierarchical namespace. So when we talk about the domain namespace, so in that we are going to be having as hierarchical namespace. And how does it actually going to be happen? So you are going to be having one of your hierarchy, and that hierarchy is actually from your level 0 to your level 127, and in that everyone is going to be having a different hierarchies, but and all it can be there, let us say com, edu, org, like that. So accordingly we are going to be having lots of domains, and based upon that we are going to be providing some names to it. Now the next one which we have is your World Wide Web. So your World Wide Web is basically a collection of the information which is linked together from points all over the world, and it is also abbreviated as www. So let me just write it down, www. What it is? World Wide Web. So what your World Wide Web is actually going to be doing, this one is going to be providing the flexibility, portability and user friendly features. So portability, flexibility and your user friendly features. All right. Now when we are going to be talking about your World Wide Web, so this one is going to be consisting of your worldwide collection of the electronics documents. So let us say your web pages, and how it is actually going to be helpful, because this one is going to be exchanging the information between your computers on the internet. The World Wide Web is mainly the network of the pages, which is going to be consisting of your images, text, sounds, everything which is going to be there on your internet, which can be simply viewed on the browser by using the browser software. So that is what your World Wide Web is going to be there. And when we are going to be talking about the components of World Wide Web, components of World Wide Web. So we have two types of components. So the first one is going to be your structural components, and the another one is going to be your semantic components. All right, now let us look into the structural, what the structural is going to be there. So it is going to be dealing with all the structural components, and the semantic one is going to be related to the semantics for the same. Now let's look into the architecture of your World Wide Web. So the World Wide Web is mainly a distributed client and server system, where a client is going to be using a browser which can access the service using a server, and the service which is provided is your distributed over the different locations, which are also known as your sites or the websites. Every website is going to be holding one or more documents that is generally referred as your web pages, where every web page is going to be having the link to the another one, because you must have seen like any of your web page. So what actually happens in that particular one, you will be having something as home, something as about, something as contact us. So what actually happens, you're going to be having access to all of those in one place, and these places can actually be retrieved and viewed by using browsers. Now that is how your request is actually going to be maintained there. Now the next one which we have is your SMTP protocol. SMTP actually stands for Simple Mail Transfer Protocol. All right. So when we are going to be talking about your SMTP, so basically, you know what you are actually going to be transferring. So you are going to be performing all your transfer of the messages using your MTA. What is your MTA? That is your message transfer agent. So in order to send a message, your system must be having the client MTA, and in order to receive the mail, your system must be having a server MTA. In order to define the MTA client and the server on the internet, so there should be a formal way, and it is known as your Simple Mail Transfer Protocol. It is also going to be using the TCP/IP for sending and receiving the emails. It is also going to be based upon your client server model, and the original standard port for SMTP was your port number 25. By using this protocol, the client who wants to send the email is first going to be opening a TCP connection to the SMTP, and then it is going to be sending an email across your TCP connection. And it is also important to note that your SMTP server is also going to be in your listening mode. As soon as it is going to be listening from the TCP connection from the client, then the connection is going to be initiated on your port number 5, and after that it is going to be successfully sending the mail. Let me show you how does it actually works. So let us say we have your user A here and some user B here. So what it will be doing, it is going to be using SMTP client, and your user B is going to be, let me draw it in both ways, and your user B will be actually using your SMTP server. Now they both are actually going to be on the internet, and this one is going to be using the TCP IP network. Now when we are going to be talking about the SMTP, so the SMTP is used when you have to send the email between your sender and the sender's mail server, and when you are going to be sending it between your sender's mail server and the receiver's mail server. It is also important to note that in order to receive or download the email, there is a need for another protocol which is going to be available between your mail server of the receiver and the receiver. The commonly used protocols are going to be your POP3 and IMAP, and these two are going to be having the mail access agent. Now if we are going to be talking about the architecture of your SMTP, so all the users are going to be using your user agent, that is your UA. The mail transfer agent, that is your MTA, is mainly going to be exchanging all the messages in between both senders and the receiver. And how are they going to be performing it? By using TCP IP. So the system administrator, who is having the authority to configure the setup of the local MTA. Thus, the users who are sending the email do not need to deal with the MTA. So the MTA is going to be keeping the queue in the pool of the message. If the receiver is not available at that particular moment, so MTA can schedule the repeat delivery of all the messages, and your MTA, that is your mail user agent, that is going to be forwarding the mails into the mailboxes of the user's local system, and then user system can download all the messages at any time. So that is how it is actually going to be there. Now I will actually be showing you how does it actually works. So let us say we have your sender here and we have your receiver here. So what is actually going to happen at this particular point? You are going to be having your user agent. So this sender is going to be using this user agent, and at the receiver end also we are going to be having a user agent which your receiver is going to be using. From the user agent, you are going to be having a sent mail queue. So it is going to go to your sent mail queue, and at your receiver end you are going to be having your user mailbox. So this user mailbox is actually sending the message to your UA. Now when you are going to be sending the mail queue, where it will go? It is going to go to your MTA. What your MTA is? Message transfer agent. And at your receiver end you are going to be having your another MTA. So these two are actually going to be built upon your TCP connection. So with the help of this, you can actually understand how the message flow is going to be there and how your SMTP is actually going to be helpful in order to provide all the commands which is going to be helpful in order to have a seamless connection between the two. Now what and all your SMTP is actually using, so it is using two things. The first one is going to be your user agent and another one is going to be your mail transfer agent. Now we'll be seeing how the communication is actually going to be happening. So your user agent at the sender side is going to be preparing the message and it is going to be sending it to your MTA. So the task of your MTA is actually to transfer the email across the network and to receive MTA. Also, in order to send the email, a system must be having the client MTA, and in order to receive the email, the system must be having a server MTA. Now we'll be discussing about how can we send the email and how can we receive the email. So when you will have to send an email, that email is actually sent between your sender and your receiver using a series of request and response messages. An email is mainly going to be consisting of two parts, header and body. So the body part of the email is going to be indicating the main message area, and it is also going to be having the actual information which your receiver has to read. So the header is mainly going to be containing the address of the sender and recipients, and it is also going to be having the subject of the email. In order to terminate the header of the email, there is a null line. Everything after that null line is actually going to be considered as the body of the message. Now we are going to be learning about receiving the message. So what happens? Your mailbox are going to be checked by your user client at the server side at a particular interval of time. So in case any information is received, then it informs the receiver about the email. At the time when the user tries to read the email, then your MTA mainly displays a list of the emails with their short description in the mailbox, and if the user selects any of the email, then easily we can view the contents inside that email. So that's all we had about this session. So I hope you were able to find it interesting. Now we will be meeting in our next class. Till then, happy learning. Bye bye, and I'll be seeing you in next class.